In 1891, a Russian mathematician named Evgraf Fedorov completed a proof that defined the boundaries of flat geometry. He established that there are exactly 17 ways a repeating pattern can be arranged across a flat surface. These 17 crystallographic symmetry groups are the complete taxonomy of two-dimensional repeating patterns. Every wallpaper, textile, or tiled floor in existence fits into one of these 17 mathematical categories. But 5 centuries before Fedorov's proof, artisans in Granada had already found all 17, working with hammers, chisels, and a geometric tradition that had been developing in the Islamic world for 600 years. They were building the Alhambra. Constructed overlooking the city of Granada primarily during the 13th and 14th centuries, the palace was the work of the Nasrid dynasty. They were the final Muslim rulers on the Iberian Peninsula, maintaining the last remnant of a civilization that had produced the most advanced society in medieval Europe. These builders lacked modern equations, yet the monument they constructed contains every possible kind of two-dimensional symmetry. To see how they mapped these mathematical limits, we have to read the building from the floor up. We start at the Alhambra's lowest layer. This zealage tilework, a complex geometric mosaic, forms the base of the rooms. These patterns physically demonstrate the 17 symmetry groups through translating, rotating, and reflecting star-shaped tiles until they cover the surface. The drive to find these patterns was philosophical. Islamic scholars understood geometry as the language in which the universe was written, an underlying order embedded in creation. At the core of this worldview is Tawhid, the concept of absolute divine oneness. This theology found architectural expression in patterns that extend infinitely from a single generative point. For the Nasrids, these designs made mizan, the divine balance and order of the world, visible in physical space. These floor tiles were an empirical, built theology. The beauty was not incidental. It was a way of proving that the physical world was governed by a precise mathematical harmony. Moving the gaze upward to the carved plasterwork reveals a second layer of mathematical complexity. In 2007, physicists studying these medieval patterns found evidence of a breakthrough that modern science has only just begun to formalize. They found quasi-crystalline tiling, arrangements of shapes that cover a surface and extend infinitely without ever exactly repeating. The formal mathematics to describe these non-repeating patterns was not developed until the 1970s, and the discovery of quasi-crystals in nature earned the Nobel Prize in Chemistry in 2011. Yet these exact properties are physically present in patterns carved here in the 14th century. By pushing their geometrical methodology to its absolute limits, these craftsmen cracked the code of non-repeating infinity 600 years before the West had a name for it. Above the walls are the wooden muqarnas ceilings. Here, the two-dimensional geometry of the lower layers scales up to 3 dimensions, representing the 7 heavens of Islamic cosmology through a structure of interlocking star forms. This same geometry dictates the macro scale of the building. In the Court of Lions, 12 marble lions support a central fountain from which 4 water channels run toward the 4 cardinal directions. This layout, called the Char Harbagh, is a direct mathematical translation of the Quranic description of paradise, a garden divided by 4 rivers. The same symmetry found in the tiles is applied here to living trees and flowing water. The entire Alhambra is a scalable mathematical model. It is designed so the mind moves continuously upward, from the base geometry of the tiles, through the infinite complexity of the plaster, and finally to the cosmological map of the ceilings. Woven through every geometric pattern is a second language, Arabic calligraphy. Poetry and verses are carved into the plaster with precision. One phrase is repeated hundreds of times, Wala Galiba illa Allah, there is no victor but Allah. In a palace built to celebrate the power of the sultans, this text acts as a theological corrective. It reminds the viewer that however impressive the math and architecture may be, all power belongs ultimately to the divine. By combining mathematical pattern and revelation in the same space, the Alhambra makes a single argument about the nature of order and the transience of human power. It is the most elaborate bilingual theological statement ever made in stone. In 1922 and 1936, the Dutch artist M.C. Escher visited the Alhambra. He spent days making careful sketches of the tile patterns on the walls. The experience changed the direction of his art. Escher's famous tessellations, the interlocking fish that transform into birds, are the direct intellectual descendants of the 14th century patterns he studied in Granada. The Alhambra demonstrates that medieval Islamic science was an engine of original inquiry. The craftsmen who built it were mathematicians working in physical material. It stands today as a physical proof of a geometric methodology that arrived at mathematical completeness. The Red Fortress remains on its hilltop, a monument that described the laws of symmetry 5 centuries before the rest of the world caught up.